Yep.
Hi.
So today we're doing special right triangles and trigonometry. So I'll let Tracy and Nora start.
Okay, so today we're going to be doing special right triangles. Ooh. Oh, okay. So we're going to be covering 30, 60, 90 triangles, 45, 45 triangles, sine, cosine, and tangent. And at the end, we're going to play a Kahoot. Okay, so first we're going to talk about special triangles. So what's a right triangle? A right triangle is a triangle with a right angle. So you see in like the little diagram, in the corner of the triangle, there's like a little square. Can you see that? How do I? Oh, okay. This here. So on most graphs, if it's a 90-degree triangle, then it's going to be like drawn with that little symbol. And that always means that the triangle is 90 degrees. So we have a little activity. If everybody can look around and type in the chat something that you see in your room or wherever you are that has a 90-degree angle.
Anything in your room. Joyce, Loy, do you guys not have anything in your room that's 90 degrees that forms a right angle? Okay, well, while you guys are doing it, I will give an example. For example, look at this book, right? It's a pretty right angle. And I have a bunch of other books that form 90 degrees. Okay. So keyboard, Zachary says the keyboard. Yeah. My keyboard is also pretty much 90 degrees. Computer. Okay.
Okay, cool. So now we have a little activity. We're going to identify right triangles. Okay. Which one of these looks like a right triangle to you guys?
Here, I'm gonna number them so you guys can better. Okay, so Zach says 3. Does anyone have any other ones?
5.
Okay.
Okay.
So it looks like 3, 5, 6. Okay, so in this situation, we would say that the right triangles in these pictures are actually only 5 and 6, and there's actually a very specific reason why. Tracy, you want to explain that?
Okay, so like in the last slide, I was explaining how a triangle in a graph will always have that little square symbol. So this was kind of mean because 3 looks like a right triangle, but we didn't add the little square in the corner. So technically it's not a 90-degree triangle because it doesn't always have to be drawn to scale.
So, I mean, the idea here is that when people draw diagrams, it's very hard to distinguish, for example, between 90 degrees and if it was 91 degrees. And so we could never be sure if this triangle is actually perfectly right triangle, which means that in the future, when we put formulas that only work on right triangles, we have to make sure absolutely that it's a right triangle. And so if we don't know for sure if it's 91 or 89 or 90, then we have to say that it's not necessarily a right triangle. The only way we can be sure is if it has that little square there.
Okay, so a couple of key terms that we're going to be using throughout this like class. We're going to be using the word hypotenuse. And in a triangle, the hypotenuse is the longest side of the triangle. And the second word would be leg. So the legs are the 2 shortest sides of the triangle. So they're the sides of the triangles that are not considered the hypotenuse.
So now we're moving on to 30, 60, 90 triangles, and we're talking about the degrees. So a triangle has 180 degrees in total. The shortest leg would be shown as x. The hypotenuse is 2 times x, and the longest leg would be x times square root 3. Like for example, if you have x set as 2, your hypotenuse will be 4 because it's 2 times 2. And the longest leg would be 2 square root 3 because it's 2 times square root 3. So now we're going to give you guys some time to possibly try out 30, 60, 90 triangles, and we'll check back on you in a few minutes.
I'm just drawing out the relationship again.
And feel free to ask any questions in the chat. And once you got answers, just type them in the chat and we're going to check them.
So keep in mind that these relationships on the side represent the relationships between each leg or each side of the triangle. So you don't actually have to know all three in order to be able to find the distance of each side. You just have to know one of them. And if it's a 60, 30, 90 triangle or a 45, 45, 90 triangle, which we'll talk about later, then you'll be able to actually find all three of the sides. So the goal is to use the information that we have right now. So we know that for this first triangle that this side is 12 centimeters. And so using that relationship, can we find x and y? We're going to give you like a minute and then check back up. Does anyone have any idea of any of the answers? I'll number them. Let's do 1, 2, 3. If not, it's okay. I know we jumped pretty far, pretty quickly. Okay, if not, let's start going over them.
Okay, so starting with number 1, we see a triangle with 60 degrees, x, y, and 12. We know that 12 is on the leg where it incorporates the 30 degrees. So we know that that side is where x is multiplied by square root of 3. Could you possibly mark that on the screen?
For x?
No, for 12. So we know that x is needed to multiply by square root of 3 in order to get 12. So from there, you need to do 12 divided by square root of 3 in order to get x, which should give you 4 square root of 3. And so from that, we get x equals to 4 square root of 3. And we know that the hypotenuse is 2x. So we need to do 2 times 4 square root of 3, which gives us 8 square root of 3. So in the end, x would equal to 4 square root of 3 and y equals to 8 square root of 3.
Does everyone know how that works? Does everyone understand how we got x and y from 12? Seems so. If you guys have any questions, just ask. I know it's not very easy. Okay, let's move on.
Okay, so for the second question, we know that the hypotenuse is 2x. So to go from 2x to the shortest leg, which is x, we would have to divide it by 2. So 14 divided by 2 would be 7. And then for the second leg, the longer leg, we know that that's 3 rad x. So you would multiply 7 by rad 3 and you would get 7 rad 3. Does that makes sense.
So the reason why we use 2x here and not root 3x like back here is because we have to look at where the right, this 90-degree angle is located. And so the hypotenuse, which if you recall from a previous slide, is the longest side. That is the side that is represented by 2x. And what is x? Well, x is the length of the shortest side of the triangle. It's this side. And so on any right triangle that's 30, 60, 90, we know that this is x, the shortest leg is x, the hypotenuse is 2x, and then the final length is root 3x. So when you approach these problems, make sure the first thing you do is you identify which side of the triangle you're working with. So in this case, it's the hypotenuse. With the case for number 1, it was the longer leg. Right, Nora, you want to take that?
Sure. So basically number 3 is the same as number 1, actually.
Okay, we can skip it.
Yeah.
Yeah.
Okay, so next we're going to be talking about 45, 90-degree triangles. And in this case, the two legs would be equal to each other. So let's say x. And the hypotenuse would be x multiplied by square root 2. So here, let's like practice it. Let's give you guys maybe 1 minute just to try this out, knowing that the two sides equal to each other and that the hypotenuse is x multiplied by square root 2. If you guys have the answers, please type them in the chat.
Or unmute and say it.
Does anyone have anything?
Come on, Zach. Come on, Loy. Joyce. I'm pretty sure we've done something like this in the past too. So this is actually a review. If you guys don't have answers, are you confused about how to do it? No? It's okay. We can go over it.
Okay. So here we know the hypotenuse, which is 16. And we know the hypotenuse is found when you do x multiplied by square root 2. So here we have 16. So we need to divide 16 by square root 2. And that will give us 8 square root 2.
And if you don't know where this step came from, you can think back on our lesson about radicals, where we just multiply top and bottom by square root 2. Right, so I can do bottom multiplied by square root 2, top multiplied by square root 2. That gives us, because the bottom, the denominator, is root 2 times root 2. That's just 2. So 16 over 2 times root 2, that's 8 root 2. So that's how we got this. And so that's also what x is. And so by knowing one side of the triangle and knowing the angles, we could find the other two sides. So that's the application of this.
Okay, now moving on to basic trigonometry. We're going to be talking about sine, cosine, and tangent. So these are ways to find the side lengths of a right triangle if you're given like the degree of a triangle and one side. But the way we're teaching this right now, we are giving it to you in a fraction form. but to find the real number, you're going to need to plug that into a calculator. Oh, okay, so for sine, the first one is sine. So this one is going to be using, well, okay, so we have like a symbol. This is similar to like the symbol like X or Y. It's just like a number that represents an unknown value. So for sine of this unknown value, it's going to be using the opposite over the hypotenuse. So if we look at the graph on the side and look at the side opposite to that and the side that is the longest, so the hypotenuse, we can use those and make a fraction. Same thing goes for cosine. Cosine is adjacent over hypotenuse. So the adjacent angle to the unknown value would be here, here, and the hypotenuse would be here. And then once again, that's the same for tangent, which is opposite over adjacent.
And you may ask, how do you remember sine, cosine, and tangent? But there's a thing called SOHCAHTOA, in which is a good way for you to memorize which sides go to which. So represents sine, which is opposite over hypotenuse. And then ka, which is for cosine, which is adjacent over hypotenuse. And toa, which is for tangent, which is opposite over adjacent. So here we have some practice questions to find sine and cosine. Remember that sine is opposite over hypotenuse and cosine is adjacent over hypotenuse. So we're going to give you a second to try these questions out.
So the goal here is just to find the relationship. It doesn't have to be one single number. Hey, Kohar. We're just in the middle of doing trigonometry, basic trigonometry. So you can just sit here for 1 second while we do these practice problems.
Does anyone have an answer yet?
No, we're quiet. We're a quiet room today. 60. Okay, so we have one answer, 60. Okay, if not, let's just go over the answer.
Okay. So since we know that sine is opposite over hypotenuse, we know that the opposite of x is the leg where it says 4 and over the hypotenuse. So sine x in this case would be 4 over 5. Okay, and moving on to cosine, we know that cosine is adjacent over hypotenuse, and in this case, it will be 6 over 10 because 6 is adjacent to x.
Koharu, I'm not sure where you got 60 from, but what we're doing here is we're just trying to find the relationship between the two sides that sine and cosine represent. So we don't actually have to multiply anything. In the case of number 2 here, so find cosine x, all we're doing is we're identifying which sides correspond to cosine. And if we look up at our, our little acronym up here, SOHCAHTOA, we know that C stands for cosine, A stands for adjacent, and H stands for hypotenuse. So that tells us that cosine of x refers to just the adjacent over the hypotenuse. And so which side, if we see that this angle, if we see that this angle here is x, which side is adjacent to it? Well, it's 6, right? That's the side that's closest to it. That's not the hypotenuse. And of course, the hypotenuse is just the longest side. And so we say that cosine of x is 6 over 10, which is also 3 over 5. It's okay. You can move on. Okay, and this one's also similar. We're just finding tangent. Remember, tangent is opposite over adjacent. It's okay, Jack. Or Jake. Right. Oh. Okay, this one was just one problem, so we're just gonna move to the answer. If no one has any answers. Oh, okay. Well, we got one. So Koru says 4 over 3. Let's see if that's right. Well, let's identify our angle first, right? So our angle is x. That's our unknown angle. And so we're trying to find tangent of x. And so if we look at this over here, we know that tangent is opposite over adjacent. Our opposite angle to x, or opposite side to x, is this length of 4. So I'm going to write that on top. And then adjacent is the length that is closest to x, which is this 3 over here. And so tangent of x is 4 over 3. And you're right, Koharu. Good job. Okay, so we're actually going to do a Kahoot, which is something we've actually never done before. You are late, but it's okay. So I don't know if you guys all have access to Kahoot. I'm assuming because it's a link. So can everyone go on their devices, type in kahoot.it, and then we'll give you guys a code later. You have to put your username in, but this is just something new that we're trying. And for the students that just joined, might be a bit difficult, but just do your best.
I have put the Kahoot number into the chat.
Tracy, can you share, or Nora, can you share the Kahoot screen?
Of course. Let me see how I can do this. I think you need to give me permission.
It's because Charcy's also sharing, but I can give you it. Okay. Yep. Well, if it's not, you can sit by and watch. We'll try to make sure, Kahoot is accessible before the lesson next time. But it's just something new, so we haven't really tested it too much.
Did you give me the permission?
Yes, I did. I did.
Wait, where's share screen?
It's on the bottom. The green button.
I don't have it.
Interesting. I mean, we can move on, and then we'll see if we can get that Kahoot going at the end.
Okay.
Because I know this person who's named useless person, you said free pass, but Kahoot's actually pretty fun. So we're gonna try to get it working. But let's just, Chelsea, can you share your screen again? And then we'll move on.
Okay.
Okay, so now we have some application challenge problems. Um, these are not the easiest ones. Gimkit or booklet. Okay, we can look into those. We can try it next time. But for now, we have some problems that are a mix of some concepts that we learned today and also in previous lessons. So we're going to give you a second to try to solve them, and then we're going to help you through them. Okay. Well, maybe a little bit more than 1 second. No, Kahoot isn't now. It is having issues, but we do want to try it, so we're going to try to fix it. Okay, I think we can go over the answer now, unless anyone has. I mean, we got an answer for Koharu, but yeah, we can go over it. Well, first of all, before we go over the actual answer, there's actually a very, very, very easy way to do this, but let's do the way that we intended. So using this relationship that I drew out on the side. Charles, you want to explain?
Okay, yeah, so right now we know that this is it's missing a lot of information, but what do we know? So like the little ticks on the side of the triangle, um, they're showing that it's an equilateral triangle, right? That means that all of the sides are going to be the same. And that means all of the angles, if a triangle is equal to 180 degrees and there's three equal angles, each angle is going to be 60 degrees. So if you split that in half, there's a 30-degree angle, right? So at the top of the right angle, we know that that's going to be 30 degrees, and then the bottom angle is going to be 60 degrees. And then the ticks on the side mean that all the angle or all the side lengths are the same. So that means that we have one complete like triangle that we can use the formulas on. So we know that 5 is the hypotenuse, and that's going to be 2x. So if 5 is 2x, to solve for x, we're going to have to divide 5 by 2. That means that the bottom leg, or the shortest half of the base, is going to be 5 over 2, which is x. And then to get from there to the height of the triangle, we're going to have to multiply it by rad 3. And then is x the base?
I think we're
And
just trying to find x here.
okay, so that would just, yeah,
Yeah,
so x
so
5/2.
what we can see from here is given one side length and one angle, even though they're not even on the same side of the triangle, we were able to find the other two lengths using these relationships. What we missed though is the fact that there's actually a very easy way to do this, because if we notice that it's an equilateral triangle, meaning that every length is 5, and we notice that x is half of the base, then what is x? It's just 2.5, right? Which is what we said earlier, 5/2. All right, so there's always a complicated way, and there's always an easy way to do it. But if you wanted to do it using similar triangle or special triangles, then you would have to relate this length to this length and then use the relationships. Yep. Okay, now this one's a little bit harder. We're asking you to find the area of the triangle now. We're going to give you guys 1 minute and try to find the answer. Can't tell if you're being sarcastic, Mr. Useless Person. But we do have an answer from Koharu. He says it might be 9. So if you guys disagree, if you guys agree, that's okay. We'll go over it in a second. Oh, sorry, Koharu. Okay. If we don't have any more answers, let's go over it. Trusty, you want to explain it?
Yeah, okay. So, once again, we have, if you look at the left side of the triangle, so the height of the triangle is going to be creating a right triangle, and you have a 30, 60, 90 triangle. So from that, we can see that 5 is the hypotenuse. And similarly to the last question, the hypotenuse would be 2x. So to get to x, we're going to have to divide it by 2. So that means that the height of this triangle would be 5/2. Now, we know that the base of this right triangle would be x rad 3. So to get the base, you'd have to multiply 5/2 times rad 3. And then if you simplify, you would get 2.5 times rad 3. And then you would add, so there's like that extra bit on the side, that's 2 units. So you would have to add the 2 units to the first base that we found to find the overall base of the big triangle. So if you add those together, you would get 4.5 rad 3. And then you would And we know that to find the area of a triangle, that's going to be 1/2 base times height. So we found the height, and that's 5/2. And we found the base, which is 4.5 times rad 3. And if you divide those in half,
Yeah, this might be a bit hard to do.
I don't
Let's
have.
see. We can do 1.25. So right here, I'm doing 1/2 times 2.5. So I'm putting these together, that gives me 1.25, and then multiplying by that. And we can't actually combine 2.5 root 3 plus 2 because the square root gets in the way. So yeah, you would need a calculator for this if you wanted to simplify the root 3, but in simplified form, you can just say this is the answer for now.
Mr. Useless Person, when you say you don't get it, is it the actual equation formula that you don't get, or is it the calculations? Because the numbers here are a little bit difficult to use.
Okay, we can review the whole thing step by step. Let's do this. So first thing when we want to approach this is we see the word area of the triangle, right? Review from last time's lesson, from last class's lesson. We know that the area of a triangle is 1/2 base times height. And then from here, we know that we need to find the base of the triangle and we need to find the height of the triangle. So let's identify those. So the height of the triangle is obviously going to be this middle line here, right? And then actually I'm going to write in a more legible color. There you go. That length right there. And then the base is this length right here. So I'm actually going to label them. So this one's the height. This one's the base. Okay, so how do we go about finding it? Well, the only information we have here is this side length 5, this side length 2, and this angle 30. So exactly as Kohei was saying right now, we need to use that one ratio that we learned. And that ratio is the ratio of the shortest length of the triangle, which is just happens to be the height this time. So we can mark that as x. That's just this height right here. And then that compared to the hypotenuse will be 2 times x. So the hypotenuse is always 2 times that one short leg. And then the long leg is root 3x. So long leg is root 3x. So what we have is the length of the hypotenuse. And so we know that 2x now equals 5. We can solve for x. So we know that x is 5/2 or 2.5. And therefore, since the height is just x, we know immediately that the height is 2.5. Okay, so now we need to find the base. But the base is actually split into 2 parts, right? Our 30, 60, 90 triangle only covers this left side here. So let's draw it in, let's see, purple. So the 30, 60, 90 triangle is only this left section here. It doesn't include this 2 here. So what we have to do is we have to split the triangle in 2 parts. First, find root 3x, which in this case is just root 3 times 2.5. And then we have to add that to this small length of 2 here. So we can say that b, or the base, equals 2.5 root 3 plus 2. So that's how we get the 2 lengths that we need. And so we can go back to our area equation. We know that area is 1/2 base, which is 2.5 root 3 plus 2 times the height, which is 2.5. And to save us time, I'm not going to simplify it, but you could always plug this all into a calculator and get a nice decimal number. Are you okay, formerly useless person? It's okay. I would suggest everyone, since our lessons are getting more, calculation heavy, from now on, try to bring a pencil and a piece of paper and maybe even a calculator so that you can do these by yourself. Okay. You can move on. All right. So this one is even harder. You don't actually need a calculator for this, but you do need a big brain. So we're going to give you 2 minutes to do this. And then we're going to go through it step by step because it's a multi-step problem. Yeah, 30 YD refers to yard. So you want to find your final answer in terms of yards. Okay, so since this is a multi-step problem, I'm going to reveal half of the answer for you guys. Okay, so if you are stuck, the first step is, again, to analyze what information we have and what we want to know. So we have two angles here, and they're all forming a side with the side of the building that we want to find. So that's a really good thing, right? We're trying to find this side, and we already have two special triangles made for us. Now, the problem is we don't know what this length is. We only know what this section of it is, and we have a variable. Actually, I would say that this isn't the height. This is the height, right? But we would only know what these two sections are. And so what we have to do is we have to find an equation that relates these two. So how do we do that? Well, we look at our 30-degree triangle right here. So if we extend it out, that goes all the way to the top of the building and then forms this big triangle over here. And so let's look at our relationships. The only length that we have is 30 yards plus d. That's the base of this 30-degree triangle. Now, if we recall from our relationships, we know that the shortest length, which is in this case our h, that's x. Our longest length is 2x, and our other leg is root 3x. And so we know that 30 yards plus d is just root 3 of x equals root 3x. And so x equals 30 plus d over root 3. And in this case, I'm actually just going to replace x with h. So I'm going to write h equals 30 plus d over root 3 because we identified that this length over here is our shortest length of the triangle, which is just our height. So from this information, we don't actually, we aren't able to find the answer because we don't know what d is, right? So how do we find d? Well, we can set up another true equation with this second triangle here, which is our 60-degree triangle. And for this, we know that our smallest length is d. So in this case, d serves as our x. Our hypotenuse, again, is 2x. And our height is root 3x. And so we know that d equals, our height equals root 3x. Now you'll notice that this equation is true. This equation is true. They're both equal to height. And so we can now write that they are equal to each other. Or I'm going to replace x with d. So now all we have to do is solve for d, right? Or actually, I said to you guys I would give you half of the answer. So we're going to end it with this and give you guys another 30 to 45 seconds to see if you can figure out the height from here. Good luck, guys. Would you like me to explain it again? Here, which part are you confused about? Oh, well, that's not something I can help with, unfortunately. Right. So let's move on. So we got one answer from Koharu. Um, but if you are still feeling confused, that's okay. We're going to go over the rest of the answer. So from this equation that we just made, we can actually determine D, right? So we're going to do some simple algebra. We're going to multiply both sides by root 3. So on this left side, that'll get rid of this denominator that's pretty annoying right now. And then we'll multiply the right side by root 3. What's root 3 times root 3? Well, by definition, it's just 3, right? So 30 plus d equals 3d. We can move this d over here to the other side. So we get 30 equals 2d. And then some simple math, we get that d equals 15. And so we now know the length of this edge. Okay, so I'm going to actually delete everything. Just remember d is 15. And then we know that this is 15 yards. So this is great because if we look at our big triangle, we can now use our relationship with an actually known value for our base, right? So our base is 30 plus 15, which is 45. And so let's just go back to our values. Our h is our shortest length, so we can say our h is our x in this case. This other leg of the triangle is our second longest length, so that is our root 3 times x. And then if we relate this, then we can say that 45, which is our base, is root 3 of x, and therefore, this is a therefore symbol. If you haven't seen it, it's just 3 dots. We can say that x, or our height, is equal to 45 divided by root 3. And if you wanted to simplify that further, it would be 15 root 3. So, if anyone has any questions, I know that this is not an easy question. So if you have any questions, feel free to ask right now before we move on. Does everyone get it? Mr. Kendo Asikiwa, do you get it? Because you were struggling earlier. Do you understand how we got 15 root 3 for the height? So I'm assuming you get it. Perfect. Let's move on. Okay. So this one involves trigonometry. I know it's been a couple of slides, so I'm going to write this down. SOHCAHTOA. All right, so this is, again, sine, cosine, and tangent, and they relate the sides of a triangle. But if you recall, you can't actually use these without a calculator. So this is actually a calculator question, but we're just going to write it in terms of tangent so that we don't actually have to solve it. So we're going to give you guys about a minute to do it, and then see if you guys can, come up with a couple of ideas, even if you can't completely solve it. Okay, we are running short on time, so we're just gonna start going over it. Nora and Charcy, do you guys wanna tackle this one? No? Okay, that's okay. So again, first step, always, whenever we see a multi-step problem, identify what we know and identify what we want to find. So the height of the building on the left side is this building right here, right? The height of it is just A plus B, okay? So I'm going to draw it out so that you can better see it. Let's let this be A and this be B. Okay, so that's what we're trying to find. Now, what do we know? Well, we have two angles that we're given, and these angles are part of two triangles, right? Two right triangles, in fact. So I'm going to draw this out in another color. So this is our first triangle here. And in green, this is the second triangle that we have. And they have different angles and different lengths that we're trying to find. But they do share one thing. What do they share? Well, they share this middle length over here, right? Because we can see if we look at the bottom, this number is just hiding here, but it's 26.3. So let's just move that up. 26.3 here. And now we actually have enough information to use sine, cosine, and tangent because we have an angle and we have a side. Okay? So if we recall back to SOHCAHTOA, we can try to identify one of these that we want to use to solve this problem. So what do we want to find? Well, we want to find this length over here, A, right? And that length is opposite to our angle that we have. So recall our angle is over here. The opposite angle is A. It's not the hypotenuse because the hypotenuse is the longest one. And the one that we have is we have the adjacent side, right? 26.3 is adjacent. And so what we would actually use is tangent, because if we, expand this out, TOA, right? That corresponds to tangent equals opposite over adjacent. Sorry, my handwriting was horrible for that one. But tangent will give us the answer that we need. And so Nora tries to, I don't know if you guys have a calculator, but can you get it ready? So we can give them a concrete answer once we're done. Maybe Desmos would work too. But so in this case, we would say that tangent of our angle theta, which is 35.9, is equal to our opposite, which is A, over our adjacent, which is 26.3. And so A, therefore, is equal to 26.3 times tangent 35.9. Okay, now all we have to do is repeat the exact same steps for B, right? So for B, we know that tangent of 54.7 is the opposite length, which is B, versus the adjacent length, which is also 26.3. And so B in this case would be 26.3 times tangent of 54.7 degrees. Okay, so now that we have this information, recall tangent, sine, and cosine, you do need a calculator to solve. If we wanted to write it out just in terms of tangent, we could just write out A plus B is equal to the height, which is what we're trying to find, is equal to 26.3 tangent, and we can actually factor it out. So we can do 26.3 tangent of 35.9 plus tangent of, so at 54.7. So what I did here was 26. I just used distributive property, factored it out. And so that could be our answer. If you wanted a very specific answer, you would have to use a calculator. I don't know if Nora, Charcy, you guys have the answer.
Okay, so if you plugged in the answer for A, you would get 18.42 approximately. And then for B, it would be 37.14. And if you added those two together, you would get approximately 55.56.
Okay, and what if you multiplied by 26.3?
For B?
Oh, no. So sorry, just repeat the answer. You just did it. You just did it different
55.
steps to B.
55.56.
Okay, so that would be our final answer. And remember to write your units, meters. So the idea here is basically we have to split this up into true triangles. And actually, Charcy, can you show your calculator to the screen?
Yeah.
So everyone, if you could look at her screen, show like the tangent button where it is. So that's
Right.
actually,
Here, there's the sine button, I think, the cosine button, and the tangent button.
yeah. So what if you, I know a lot of the calculators that we use in like elementary and middle school, they're very simple, right? They just have your numbers, they have addition, subtraction, maybe even square root, maybe even like exponents. But when you get like a really fancy, expensive calculator, they will have a lot of buttons on them, and one of those will be the trigonometry buttons, so sine, cosine, and tangent. And when you get one of those calculators, then you can do problems like this easily. But this was just an intro, so we didn't make you guys, find the exact answer. But that's actually all the problems we have today. I know we had some problems with Kahoot, and I mean, do you guys still want to do it, or can we save it for next time?
We're trying to figure it out. We can save it for next time.
Okay, so we wanted to do something fun. Didn't really work out, but we will try it next time. If Kahoot doesn't work, we'll go by, I don't know who mentioned Gimkit, but I've also heard of Gimkit. I know it does work. So we'll try that. And yeah, that's basically it. So everyone who came, thank you guys for coming. Um, Thank you to our new instructors too. Yeah. Bye everyone.